Okay, I think we can start. If you haven't scanned the QR code, I'm giving you a couple, maybe a few, 1 minute to scan now, and we will start right away. All right, I think we can start. So I want to a little bit review what we have done um, on the first session last week. Okay, so our first session is basically this is what you have submitted. Uh, your feelings towards mathematics, difficult, complicated, confusing, anxiety, uh, math. Okay, let me say this. If you are thinking about math, okay, it's actually part of uh, most of science, engineering, and any general science. They all need math, right? So even though it's a complex, difficult, complicated, math is still a useful tools for all those things. Okay? And also not just only tools, it's a principle. Okay. So this is what you have, all the words that you are that you have maybe over the years you get in touch with math, right? But why is it difficult? Why is it confusing or complicated? I think because of our learning system. Uh, Most of the time, we are learning the math by looking at the formula and then memorizing the formula, right? You know, the formula for triangle, formula for geometry, how to solve the quadratic function, and so on and so forth, right? But we are not really sure why it happened. Okay. Now, what I want going to do is we start with what is math and what is the building block of math for the first half hour or first hour. I will going into details. Okay. So I'm asking that what is the building blocks of math, right? And most of you are answering numbers. Numbers, number, and number. Um, in a sense, that's true. It's a number, but let me going more detail. If we're thinking about matter, for example, like the apple, like this one. Of course, it will compose of something, right? Compose of, okay. And most of the time, and we know from physics and chemistry that there are several scientists that already found that okay, we have an atom, right? And probably you are familiar with this. You have the the atom, and then you have the electron that rotate, right? And I think for today's science, we know now that it's not only electron, okay? It's not only electron that is moving. In those electrons, we have quarks, right? Leptons, bosons, and so on and so forth, right? But still, for the mandatory science that you need to know, at least until this electron, you know, right? From the textbook from high school. Right? But actually, there's more than that, and we still don't know if we can find more things in the future. We still don't know what will we find, right? Now that is matter, any materials, right? But how about math, right? You guys answer numbers, and I say it's in a sense that's correct, because usually you learn math for countings, right? Calculation, measures, the length. You are using numbers also, right? Let's make a simple way learning math when you are still maybe a toddler, okay, maybe under 5 years old. How to count a thing, okay? Remember that when maybe your mother or father told you that, okay, you have an apple, right? Oh, you have 2 apples, right? Because you can see the apples, 1, 2, you can count, right? But then probably your father brought another fruits, right? Let's say it's an orange, right? It's an orange. You can say it's 3 orange, right? And then you make some addition. 2 apples plus 3 orange. You have 5 in total. 2 apples and 3 orange. So by looking at these apples and orange, okay, you see that you can sense that you have 2 different things, right? Okay, so you can mark this as all apples, and you can mark the bottom one is all orange, right? So you have a sense, okay? You have a sense. So actually, math is numbers and sets. Why I need to make this as in the definition? Because number, there are a lot of variety of numbers, right? It's not only like 0, 1, 2, but you also have the negative side of that, right? You also have the rational one, and so on and so forth. Okay, let me go through the okay. What kind of numbers that you can find, right? It's confusing. Oh, there's a lot of numbers, right? But I believe all of the high school curriculum, you guys already learn all of this, right? Okay. If you maybe not recognize, probably you forget, because it's not really used in frequently. All right. The first one is this inside here, the natural numbers, the number that you are learning the very first time. The one that I showed you before, that's natural numbers. because you can only start like there's nothing and then 1, 2, 3. Okay, and then you learn about the, so this is this is the natural, and then the next one is the integer. Okay, and this one is the rational, and this one is the real numbers, and the last one is the complex. Okay, so usually what realms we are talking in math and maybe in calculus, usually we are talking in real numbers, but sometimes we are talking about complex, but mostly real numbers. So real numbers is including all the numbers from the natural, integer, rational, and irrational also. So this is plus the irrational one. Okay. And then you begin to learn the addition, right? And then subtraction. And how about subtract with the same number? You learn how to make a zero number that is from India, the zero number. And then you learn to what if this happened, then you learn the negative number, right? Okay. Okay, this is, I think you already know and how to use it, right? Okay, next part, let me tell you, let me mark what is important here. Natural number is a number that starts with the 1, 2, 3, 4, okay? And an integer is all the, maybe you have -4, -2, -2, 3, 2, 1, 0, okay? And then rational, yeah, you can start with like, this is just a random number, not really in order, okay? I'm just showing you how, okay? I think for over 7, not there is a rational and irrational. In definition, have you can you tell me what irrational means? I think in a sense you can probably you have heard yes, true. Irrational, probably you can imagine like in the movie, or maybe if you watch television, sometimes in English, sometimes the person tell you that you are being an irrational one, right? So that means it's not about making sense or not. It's about here. We have the rational that we can make these fractions, right? We call this rational, but there are other number that's it's the so here we can make it into our decimals, right? So like 1.7, and this will be 0.6, right? There are some decimals that difficult to be shaped as a fraction, right? Okay. So blessing, basically that is correct. Okay. So irrationals. So here's the rational, and irrational is here. It's taking out from the rationals because it cannot be in a fractions. Okay. What's the example? There's a lot of. I think this very popular by the golden ratio, right? What other and other number? Okay, and then you learn rational, irrational. Both of them is a part of our real numbers. Okay? So all of this number, natural, integer, rational, irrational, you can group all of them and you can say, okay, that's a real numbers. Let me write here all, okay? But then, okay, we learn also that there is some numbers that we say it's a complex number. Usually you are writing in a plus bi, a complex words like here. So a and b is a constant. Okay, this is a constant, and I is a new terms to mark that if you see any is, you can taking into I is for imaginary numbers. So it's beyond real. So it's we cannot draw the real graph for imaginary because it's different from real. But we can mention the complex or the imaginary numbers in a real and imaginary graphs. So this is a real number. This is imaginary. So this is we call the real plane, and this is imaginary plane. Okay, but this is for. I'm not sure I will going to teach you this or not, but this is actually in the basic math. Okay, but at least the complex here you need to know. Okay, so whenever you find, for example, you can write this as 5i. Okay. All right. So this is the numbers. I hope you guys know what I'm saying. And then the next part is the addition, subtraction, multiplication, and division. I believe all of you are familiar with and already using it for many times, right? So addition and subtraction, we already done that. And so on and so forth. And you already know how to make the negative out of the multiplication or the division. But we learn here multiplication and division. So what is multiplications? In a sense, multiplication is repetition or repeated addition. So for today's for maybe a half hour, I will undo what you have learned from math before and try to weave a new, not new, but weave your understanding on math. Okay. So we have a repeated addition. What does that mean? That means if I say 3 multiply 5, this means 3 plus 3 plus 3 plus 3 plus 3. Okay. And division, let me put the division down here. Division is repeated subtracting, or you need to undo the multiplication, right? So for example, if you are divide 21 with 3, it's actually 21 minus 3 minus 3 minus 3 minus 3. Until it's finished, right? 21 minus 3 minus 3 minus 3. It's 7 times. 1, 2, 3, 4, 5, 6, 7. So 7 times. 7 times needed for 21 to become 0, right? Okay. Now, wait. What will happen? I think we have done in calculus class, I think. But if we want to divide 1 by 0, what will happen? Okay, so if you agree that multiplication is repeated addition, so we add, if we multiply 3 by 5, 3 plus 3 plus 3 plus 3 plus 3, 5 times, right? So 1, 2, 3. This is 1, 2, 3, 4, 5. Okay, and then we are subtract the for the division, we undo the multiplication. 21 minus 3 minus 3 minus 3 minus 3. Okay, this is the definition. So if we have 1 divided by 0, what will happen? We want to make a repeated subtracting by looking at this division. So 1 minus 0 minus 0 minus 0. You cannot have anything, right? So how many times we have? Then you learn about these symbols, right? Or in some cases, if it is a function, you say the function is undefined, but later for that. But we learn there is something that is beyond our measures, beyond our calculations. Okay, another sense to make this more more understandable. Okay, let's consider this 1 over 0 here. And let's say we consider from 1 divided by 1. Okay, all of you know that this is just still 1. Okay. All right. 1 divided by, let's take some decimals number. Some decimals, 0.1. Then this is making 10. Okay, still easy, right? Still easy, right? And 1 divided by 0.01. Still easy, still 100. You can measure that. You can calculate that easily. Okay, increase one more. We get 1,000. Let's try to increase the decimals. How many times 0 there? 1, 2, 3, 4, 5, 6, 7. Okay, it's quite big. We have 10 million. And you know that if we increase more and more decimals here, so if you increase decimals, what will happen? It's getting larger. And when your decimals are beyond your counting, you get the infinity, right? Okay. Okay. Now we make the same thing. This is for 1. What about 2? If we have 2 divided by 1. 2, right? Okay, 2 divided by 0.1. We get 20, right? We get 2 divided by... Okay, still, it's pretty similar, but it's twice now. Twice as much as the previous number 1 before. And we get the other... and we get 2000. And still, if you have more decimals, you get more and more 0, right? And still you get the infinite. So, okay, you get some conclusion, and can we write this? Oh, it's infinite. It's the same as our. So, can we write this? What's happening here? Yeah, can we write this? So 1 is equal to, because it's when we divide 1 divided by 0 and 2 divided by 0, it's still same infinity. So 1 is equal to. Okay, we have a new definitions now. We've invented new method in mathematics. Okay, how about that? So do you agree this happened? Yes, it's wrong. Why it's wrong? Ah, good, Hans. Good, good. Infinity is beyond calculations. Okay, so it is not. You cannot calculate the infinite. It is an abstract, actually. So here, so this is the terms. This is abstract terms beyond calculations. So why people referring to the infinite as in, okay, it's really big, because they cannot measure what number exactly is the infinity is. Okay, right? Okay. And another way to look at the infinite, we also have the negative part of the infinite, right? We call the negative infinity. So if you have 1 divided by, maybe you have the negative here, you have 0, right? Or if you are going to have the terms, it will be the negative of infinity. So you have the positive and you have the negative, and both are abstract terms beyond calculations. And sometimes we just saying that the numbers that is being divided by 0 is undefined. In some cases, it's okay. You can just write infinity or negative infinity. Okay. But if it is the case on functions, usually you need to write it's undefined. All right, so that's a little fundamentals about numbers. Okay. Another thing I need to mention is the real line number, or usually you are seeing any like this one, and you have maybe a number inside. Maybe start from -4. Okay, let's say you have this, and then you also have, if we are talking about real line number, so all the things that are in betweens of this number, like rational, irrational numbers, if you have, then you can also mention that, and it is becoming part of this line number. Okay, so for example, you have in between 1 and 2, maybe you have square root of 2, square root of 3, right? And then between 2 and 3, you have a square root of 5. Okay, and maybe around this 3, you have pi, right? Okay, and you have also the negative part here, the negative part here, negative number. This is just to show you that when you're dealing with real line numbers, and maybe you are measuring what the domain of the function is, or range, or anything that is using a line number, you need to think carefully of other numbers that are not really in this line, but actually they are in this line, but it's usually it's not written. Okay, this is just to make sure that you don't forget this numbers in between this line point here. Okay. Right. The other thing is the sets and intervals, and how you write the notes in math. Okay. Okay. A set is a collection of objects. Okay. It can be anything actually, because we are now in the realm of just a general mathematics. Okay. Not only calculus. So general mathematics. So it can be all objects. We can make it into variables if you want. Okay. And these objects are called elements. Usually we say sets in terms of S. Okay. If we write A S like that, this means A is an element. This is the terms for element, the symbols, element of S. Okay. If we write B and then we are making symbols like this means it's not element of S. So B is not element of S. Okay. Okay, and we can also listing the members, okay, or the numbers. Okay, so like for example, set of A, we have set of A 1, 2, 3, 4, 5, 6, 7. Maybe A is all positive. This is just a random example. Okay, positive integers less than 7. We can also write in listing. And then we can also write in terms of the notations. This is called the set builder notation. Usually we write X the same A that is all positive integers less than 7. And we can write in a set of notations like this one. So how we are going to read this is A is the set of all X such that X is an integer and 0 less than X less than 7. Okay. So we can mention what the set is. Is it an integer? Is it real numbers or complex numbers? And then we can mention the interval. Okay. And aside from the sets and intervals, we can also have the union. So if we have if S and T are both sets, okay, and we can have S union T set that consists all elements that are in S and T. Okay. And then the second one is the intersection. So if you have this, then this means a common part of S and T. And we can also have the empty set. This means there is no element inside the set. So set that contains no element. Okay, a little bit example, but I think you already know how, but this is just a review. Okay. So if, and then T is 4, 5, 6, 7. And phi is 6, 7, 8. Questions is find the union, find the intersection. Okay. Yeah, try. But is it too easy? If it's too easy, I will just write down here. So union, but I would just want to make sure that you get my point. You can try first. Because last year there is I think 1 or 2 students, but not ITP students. He is still confusing about this, and also confusing about other thing in algebra. All right. S union T. I think for A, I think a little bit mistake for blessing for A. Oh, S union T. Yeah, for B it's correct. 1, 2. Oh, really? B. Yeah, Jordan, you correct. Jordan, you correct for B. For A, okay. For C, it's intersection. Is there any intersection for S and V? Yeah, C is empty. Correct, Helena. Correct. All right, so you need to review this. That's why some of you fail your mathematics test. Okay. Okay, it seems easy because it's just a simple way. I think you learn set and interval elementary or junior high. I think elementary school, right? Or junior high. I forgot the curriculum. Junior high, right? Or elementary. I think elementary, right? You learn about the integer, the rational, at least the rational. Yeah. Okay, so first is the union. So the key, okay, if you see this, it's actually quite easy. Like it's a symbol U, and you just keep thinking, okay, union. What union means? Union means going together. Okay, so you put two sets together. Okay, so to put two sets together. So S union T, so you put all the number together. So 1, 2, 3, 4, 5, and then in T is 5, 4, 5, 6, 7. So you add all number. And do not think about V because this is only S and T, right? And then we got the second question, the intersections. Okay, look at S 1, 2, 3, 4, 5, and then T 4, 5, 6, 7. The common numbers here that intersect, right? So you can also, if you remember the Venn diagram, okay, you can also imagine this in a diagram. Okay, so this is 1, 2, 3, and you have 4, 5 here, and then 6, 7, and this is S and this T. You can also draw in diagram, and it's much more visuals, right? So we have 4, 5. That is the common numbers. And then for the intersection of S and V, you have S 1, 2, 3, 4, 5, and V is just 6, 7, 8. So there's no common numbers there. So we can just say this is an empty set. Okay. Okay. Maybe a little bit some or maybe in the new slides. I will make new slides, right? Okay. If we have this, okay, this the line number, and sometimes you will see you have, let's say, A, B, and I will make the line. Okay, I will have this line A, B. We call this is open interval by looking at this the dot. Okay, it's open dot. Okay, so this is open interval, and we write the interval as A, B with a bracket like that. Okay, and then we have Okay, we have also here, let's say this is also AB, but here we have the closed dot. Okay, the closed dot is called, we call this interval closed interval. Okay, and don't mix this bracket. Okay, don't make this mix this bracket, especially in calculus. Okay, we can also write this in inequality like this, and here is for the closed interval. Okay, and we can also mix the open and close. For example, if you have so maybe it's open here and close here. So we will have A and then B, which means A is not included, but B is included in the interval. Okay, so you can also write this in terms of inequality like that. But also, you can also have only one side. Okay, so maybe this is just B like that. So we can think this as from all the negative parts in here. So we can write until before getting into B. Okay, that is the line number, the interval. Or you can write this as x less than B. Okay. Or if you want to write the set completely, you can write this as x is between A and B. This all is correct. Okay, if you just any interval writing, you can choose which one you like. Okay, and if we have this interval, and the way you write for infinite, you will not see infinite in this form. Okay, because infinite cannot be included in numbers because it's beyond numbers. Okay, so this means we can also write like that. Means the all set of all real numbers. Okay, all right. Okay, I think one more fundamental thing, and then I can going through the some problems. Okay, all right, let's move on. Do you have any question here for the interval? I think it's quite clear, right? It's still the same as what you've learned before, right? Okay, I just want to make sure. Okay, and this is a review which one that you are frequently making a mistake. Okay. 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 Next part is the absolute value. Yeah, absolute value. All right. The absolute value, for example, if you have this absolute value of A, so this is how we write the absolute value, denoted by these terms. This means a distance from 0 to a. On, let me write completely, on real number line. And distance is always positive, right? That is a will be greater than 0. And the definitions, so if a is a real number, then the absolute value of a is, okay, this is if a is greater than 0. This is if a less than 0. Actually, you can also write if a greater than 0 or a less, both are correct. But usually, in terms of definition, usually most of the books will write this one. But both are correct, actually. Okay, this is the definitions. And because we are talking about distance in the absolute value, we can have a distance between points in a real line. So if a and b are real numbers, then distance between a and b on the real line okay. Yeah, this is the absolute value and distance. I think it's very clear, right? Okay, any questions from here? The next section is about the exponents and radicals, but I think I can make it very, very quick. And then we can go to some algebra and yeah, if we have time, I will give you some problems to check. Yeah, okay. Okay, that's absolute value. So all this stuff from the numbers to absolute value here is the fundamentals fundamentals in mathematics. Okay, we learn about numbers, and after this we will learn, or we will relearn, because all of this I believe you already learned. So we will review some of the exponent, radicals. Yeah, I think that is usually you are making mistake, and then maybe some algebra expressions. Okay. All right. So let's move on. This is the exponent. Usually, this is how you write the exponent. So if you are having we call it the power. Okay, the power. So we start with if we have 2 with power 5 like this, which means this is, you need to multiply 2 5 times. Okay. So if we have just an a and n, which means you need to multiply n times. Okay. A multiplied by a multiplied by a, n times, or n factors. We call this a, in this exponent terms, this is the base. Okay. And the n is the exponent. Okay. And we can also make, if you have -3, 3. So we have -3, -3, -3. Okay. We also make it like that. We can also make a, m, and a, n. The same base, but different exponent. So we can have a, this is m factors, and multiply with a, and this is n factors. And if you multiply both of this, we will have a. Let me make a little bit longer to show that this is already been multiplied. So we will have a, m plus n. Okay. So this is how you write the exponent if you have the same base and then different factors, and you multiply both of them, and you can write a, and then you add the factors m plus n. Okay. In the same way, if you have a, m, a, n, similar way with the previous one, but now you have the minus. Okay. And what happens if you have a, m, and then you have another exponent also? You can multiply those two. Okay. If you want to make sure, you can try maybe the number 2. Okay. So you have 2 is 4. So it should be 2 with the power of 6, right? But you can make sure you have 4, and then you can make it into cube. It's what it is? 4 is 16. 16, yeah. Okay. And then you have a, b with n, and you can separate this and making if you want to simplify. And if you have a over b with n, you can also separate this. And if you have the negative n, you can switch sides. And if you have the negative exponent, you can also switch this into this. Okay, I think it's quite easy. But if you feel you need more times here, let me know. Okay, let me know. Okay. If there's no questions, I believe this is just a little bit review for exponent, and I will go for one more of radicals. Okay, let me write another page for the radicals. And then in radicals, we also learn how to rationalize the denominator. Usually we have, like, for example, you have this 1 over square root of a. Usually you need to rationalize, which means you need to multiply this with the same radicals like that. And then it will making these terms. Okay, and we call this in standard form. And probably we are looking for standard form in some cases. Okay. And rationalize also quite useful for some problems in calculus, especially for limit. Okay. I want to go to algebraic expressions now. But let me go to I believe for the polynomial you already know, but let me just write for the very beginning here. This is a general term of polynomial. General terms or general formula. A0, A1, AN, all are real numbers. And N is non-negative integer. If AN is not equal 0, then polynomial has a degree n. Okay. And this is terms of polynomial. So you can have monomial, binomial for terms, trinomial. You can have a lot of polynomial, depends on the degree. Okay. I will going into polynomial a bit later. Let me go for some formula in polynomial that you already know, but I want just to make sure. So if A and B are real numbers, so you have A plus B, A minus B. Okay. So usually this will be A squared, right? Plus AB minus AB minus B squared. Or we can say that this is A squared minus B squared. Okay. So whenever you find this, you will get this. Or if you get this one on the right, you can directly make into a factor. And if you have A plus B squared, you will get A squared plus 2AB plus B squared. I think this is all clear, right? And if you have minus, then you have minus in the middle here. And what about if you have A plus B cubed? So you have A cubed plus 3A squared B plus 3AB squared plus B cubed. Okay. If you have A minus B cubed, okay, some squared formula for in polynomials usually. Okay, now we have this squared, and like I said before, if you want to move from the right, then you can factorize, right? And now we are moving to the factors. Any question from here? Okay, if not, then let me move on to the factors. Okay, factoring. Okay, let's try this. How to factors this? Okay, this is just a factoring, not really necessary to find x like equals 0. This is just to try to make out the factors. Okay. Okay, 3, 4. But if you write x equal 3, x equal 4, then it's wrong. Yeah, if you will need to write in x, it should be minus. Okay. Okay, so this will be x plus 3, x plus 4. Okay. But because I'm not looking for any x now, I'm just looking for the factoring. So this is just okay, right? Okay, if you have, what else? Let me go for some example. Okay, how about 6x squared plus 7x minus 5? Can you factor this? I just need the factors, not the x. Okay. 6x squared plus 7x minus 5. What is the factor? 3x plus 5 to x minus 1. Yeah, correct. Okay. But usually, if you look at the very first terms here, uh, it's not too difficult because you know that the x is just x, right? So x multiplied by x, and it will be x squared, right? And what you need to look for is how can you get 12 in multiplication, and then addition will get 7, right? Because this is x squared here, you get plus 3x and then plus 4x, right? From this 3 and from this x4, you get 7x. And then plus 3 multiplied by 4, it's 12. I believe it's easy to do it in your mind, right? But the second case, it has 6. So probably in your mind, if you are just using your mind, not really paper, you are having, oh, how about we have 1 and 6, and then 2 and 3, or 3, 2, 6, 1, right? So we have several ideas here. But here we can just have 2 possibilities, right? Just this and this, right? So instead of playing minds like this, I will give you, this is my suggestions, but actually it's up to you. I'm usually using this like a table here. Okay. Now what we are going to do, we are just fill in some numbers. Okay. Fill in some numbers in the left here and in the right here. Okay. In the left, we can write maybe 3, maybe 2, or maybe 2 or 3. That's up to you. And maybe here is maybe the first one we are writing 1 and minus 5. Now what we are going to do, we are cross multiplying here. This become negative 15 plus 2. It's not equal with this. So we need to make some changes. So maybe 5 and negative 1. Because this will be negative 3 here, right? This negative 3. And this will be 10. 10 minus 3 is plus 7. And that's why you have 3x plus 5 and then 2x minus 1. This is my personal method to going fast calculating of polynomials like this and find the factors. If you want to take this as your method, that's okay. This is a really good one. If you are familiar with this, you can go faster. So you know that through 3, and then you can do this table in your head. You can do this table in your head, and you will be counting, or you will be finding factors more. For what? Quadratic formula for what? Helena, for what quadratic formula? Finding x? But I don't want to find the x. I just want to find the factors. That's the thing. Right? Okay. At the very beginning, I'm not saying I want to find the x. I want to find the factors. Okay. That's the thing. And many people, I believe, in this quadratic function, or in this polynomials, especially in quadratic, most people are too dependent on quadratic formula. The formula, I would say, it's really good, it's really useful. But if you can do the factors easily, then just use the factors. No need for quadratic formula. If you're too much depend on that formula, you will lose your way in algebra. I will say that. Okay, you will lose your way in algebra. And most of the students fail algebra in calculus. They fail in calculus because they are not having their basic algebra very well. They don't have the foundations. And that's why I'm telling you this. The factors is I believe is much faster than using the quadratic formula. Do you want to find, like, for example, I need to find this first. And then blah, 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 blah. And then I need to count this, count this, count this. If you are using calculators, maybe you will be safe. But in my case, I will forbid calculators in math and in calculus. Not because it's bad for you. If you are too dependent on calculators, I think it's not good for for your future. But of course, in homework you can use calculator. But in exam, I will forbid the use of calculator. And if you feel the question is too complicated, then you need to simplify the questions. Okay, and then you will get the answers easily. Okay, that's it. This is just my personal taste and method to check the factors. Okay. Another important is the special factoring formula. I believe you already know this kind of factoring. If you have this, I think I already make this in the previous slide. So you have the a plus b and a minus b, right? And this is quite useful when you are simplifying terms in algebra and especially in calculus. Okay. And if you have a you can have this, and this become a squared plus ab plus b squared. And if this is positive, then we can have the positive one here. Why don't we use 6 and 1 in the factor instead of 3 and 2? Yeah, you can try. You can try here. You can try. This 6x squared plus 7x minus 5. Okay, we try. 6, 1. Okay, maybe 5, 1. Negative? No, right? Or maybe it's positive, it's negative. 6 minus 5, we cannot get 7, right? Or maybe we change this into 1, 6. 1, I think still no. Still the same results, and it will be failed, right? So basically what I've done here is not like you will get the answers directly. You need to try by yourself. And the more quicker you are in finding the number, you will get the answers really, really fast. Okay? You got it, Blessings? Okay. Right. And the thing is about the perfect square. So if I have x squared plus 6x plus 9, okay, what is the main idea, okay, in the perfect square? Why we call it perfect square? Because when you have this, you can make it into x plus 3. You get it easily. Okay, how? Look at in the middle and look at the last terms. You can write this in terms of 3 squared, right? And you need to have 2 multiplied by 3x to become 6x. You see, this is 3, or maybe 3 multiplied by 3, or maybe 3 squared is also okay. You will see that the 3 is actually half of this 6 here, right? And that's why we can write this 3 here inside here. Okay? Same thing with when you are having x squared 4x plus 4. So the key is the terms in the middle, divide by 2, 4 by 2, you get 2. Okay? And when you get 2, you check when you squared this, it's basically 4. Same thing here, right? And that's why you can write x plus 2 squared. Okay. Here. Okay. All right. Okay. So this is, we call this a perfect square. So this is perfect square, and it's quite useful in some cases to simplify terms in algebra expression. Okay. Still have time. I will continue a little bit. Okay, a little bit. So we already have from the numbers, you already know that why we cannot really define this, and this is, it seems to be infinity or undefined, right? So whenever you have 1 over x in your equation, this means that we have a set that the number, if you put 0 here, we cannot do that, right? We cannot do that if you want to make it a real numbers, right? So what we can do is we need to make restrictions, and that restrictions is basically the definition of the domain. Okay, so the domain is actually algebraic expression, or maybe it's too much words there. Let's just say the set of real numbers that the variable, in this case x, is permitted to have or allowed to have. So for example, this 1 over x here, I can say that the domain is, let me write completely x, and x is not equal 0. And you can have all other numbers. And also, you can also have the square root, right? And you can also make the domain for square root. We cannot have this a negative because we want to have real numbers. Of course, if you want to have a complex, you can have the negative and you can have the imaginary number, the I, right? But we want to have a real numbers here. So that's why the domain will be 0 can put inside, right? So we can take this as our domain. Okay. And we can combine both 1 over squared of x. And what will be the domain? It's basically the combinations of x not equal 0 and x greater or equal 0, which means because it's not equal 0, then you need to remove the equal on the second equations, right? So you can say that this will be, okay, got it? I think it's pretty simple as long as you stick to the rules, okay? It begins to have complications when you have more and more combinations and complicated algebraic expression. Okay, because this problem, the domain problem, always every year in the exam, student making the same mistake. So don't forget this. Okay, don't forget this. And then I believe all the fundamentals we already have now. Actually, there are other fundamentals like a circle, but I believe I will skip that and probably give you later in the later part. And about lines, what else we have? Okay. And I will skip some the complex numbers. I think I will just mentioning that not really in a specific problem. Okay. 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 If I have this expression here, find x. Okay, how about this? You have x with power of 4 and then minus 3x squared plus 2. Okay, anyone got x? Any idea how to solve this? Yeah, can you do that? Quadratic formula? Can you do quadratic to 4 the power of 4? Then how you are going to solve this? And wait a few minutes for you to think. Or maybe I'm just giving you this. Okay, I will wait. And maybe I will try to maybe explaining tomorrow. But actually, it's not too complicated. I will wait for a few minutes. Okay. Anyone fine? Substitute the x with what? With the numbers that you can find. Yeah, that's one way. That's one way. And that's true. We can check. Maybe you can check with the simple numbers. If you have this in like a simple numbers, start from 0, 1, 2, 3, right? That's one way to check. And I think in some cases, it can be faster when you substitute the x, especially for a simple number. You'll be getting the answers really fast. But I will tell you the idea. It's the substitutions. Okay. Yes, correct. Correct. Good, Ardian. Good. So you can substitute the x squared with some variables. So for example, you have a squared minus 3a plus 2. And you can easily get what we'll get here is a minus 1, a minus 2, right? So you have a is 1 and a is 2. But we still not finished. We need to break this a into x squared equal 1 and then x squared equal 2. So you will have x is plus minus 1 and x is plus minus square root of 2. Okay, get it? So it seems intimidating, it seems provoking, but you can actually use the substitutions for some parts here, and it will become just a simple quadratic formula, right? And you can factor these expressions easily. Okay, it's one way to solve. Okay, it's the end of our lessons, and I will go to prepare a smartphone, or maybe if you have pen and paper. Do we need pen and paper? I think yeah. Just prepare a smartphone. Okay. Okay. Okay, are you ready? Okay, please scan the QR code. OMG. Okay, waiting for you to come in. Okay. We have 6 now. Okay, get ready. Where's the other? Okay, 7. Okay, get ready. You prepare your smartphone. Mm-hmm. And when the quiz started, please use your name or student ID. Okay, let me present the. Okay, it's only 7 people, and we have 12 in now in this room in the link. Where are you guys? Are you listening now? 8. Okay, it's increasing 8. 4 more students. There are students who are not included in the quiz session. Okay, on the 8. 8. Okay, I will just start the quiz right away. Okay. All right. Get ready. Okay. Pick your name. Okay, 10. Okay, good, good. 2 more students who are not included here. Okay, anyway, I will start right now. So 3, 2, 1. Okay. Answer fast to get your point. Have around 30 seconds to answer. Okay, 10 seconds, 10 seconds. Just answer randomly. If you're thinking too hard, just answer randomly. 5, 4, 3, 2, 1. Time's up. Okay. Okay. Most of you are getting the answers correctly. All right. Okay, let's move on. Let's see who are the fastest. Okay, who's number 4? Okay, good, good. Okay. Get ready, get ready. Is it true or false? Is it true or false? Okay. Oh, it's more around 50-50 for 6. It's false. Pi plus pi, 2 pi, pi minus pi, it's 0. So it's not always given an irrational number, okay? All right. Who's the fastest? Okay. Oh, still number 4. Who's number 4? Okay, congratulations. Okay, congratulations. Okay, and this will be the end of our lesson today. Okay, see you tomorrow. Okay, see you tomorrow. Okay, I will stop the recording.